Now, here's a question. Find the distance from 1, -2, 3 to x plus 2y plus 3z equals 2. Now, definitely it's not 0, because if it was 0, then this would be on the plane itself. You plug in on the left side, you get 1, -4, so 1 minus 4 is -3. 3 times 2 is 9, so you get 6. It doesn't match with the right side, so it's definitely not the same. So to find this answer, you make use of the property of the projection. So here's what you do. Let's say this is 1, -2, 3. And the normal vector, what's the normal vector? 1, 2, 3. So this is a normal vector, 1, 2, 3. And if you pick any point on the plane and think about its normal vector, then you can think about this vector, right? You can connect any point on the plane to the point in question, and then let's try to draw this normal vector as a quite lengthy one. Right. So let's say you have this vector. Now, what distance are we looking for? By distance, what does that mean? It means we're looking for the length of this straight line, which will be perpendicular to the plane. So basically, we're looking for the following. Is there a straight line which passes through this point and crosses this plane perpendicularly? If so, what is this length? That length tells you the distance between a point and the plane. That's how it's defined. Right? Okay. Now you can go about this problem in the following way. You can actually construct a line that passes through this point and it's perpendicular to this. It's not that hard, right? And then once you find it, then you can figure out at what point it actually crosses. You can find the intersection between the line and the point of the plane. Okay. And then if you have then all you have to do is find the distance. Okay. Actually, that's 3 steps. It's quite long. So here's a simpler way to think about it. Just pick arbitrary point, right? And then make this vector, and then compute this projection. Finding projection is not that hard. And if you think about this length, the projection is exactly the same as this length, right? So that will be the second way to do it. So let's try that. All right. So first, just pick any point on this plane. Can you find any point on this plane? Any triple of numbers that will satisfy this equation? Okay, 0, 0, 1/3, right?
1, 0, 0.
1, 0, 0.
1, 0, 0, that's easier, right? 1, 0, 0, that's easier. Okay.
Yeah.
It doesn't matter which one you pick. Okay, so let's just say 1, 0, 0. So here's the picture. We have 1, 0, 0, and I want this vector. Okay, so let's do that. So 1, -2, 3, minus 1, 0, 0, which is 0, -2, 3. Right? And then if I call this vector as PA, what we are trying to do is I want to project or find a component of the vector PA in the direction of the normal vector. We don't want the vector the projection as the vector, we just want this length, right? And this length is just called a component of that vector, okay? And I want to use this because this has a simpler formula. What's the formula? You do the dot product, right? What do you do? Divide it by?
The norm.
Norm of which one? Which information do we want to throw away? The length of n or length of PA? Length of n. PA's length is the one that's important. If PA is long, the projection will be long, so we want to keep that information, right? For n, all we care about is the direction. So n's information is not needed. So we get rid of the n's information, so we divide. Okay. All right, so we have that, and then the dot product between the two is the following. We have, what's the normal vector here? Normal vector. 1, 2, 3?
Yep.
So we have 1, 2, 3 dotted with 0, negative 2, 3 divided by square root of 1, 2, 3, right? That's the norm, which gives you negative 4 plus 9, so 5 on the top, square root of 9, 10, 14. That's it, that's the answer. So it's rather simple, right? That's the distance between the line and the given point. Actually, if you look in the book, there's a formula which just bypasses everything. But if you think about it, it's actually the same thing as this one. Okay? All right. Now let's think about another case. What if you have a point and a line? So if you're given a point, so it's the same thing. 1, negative 2, 3. To the equation, say x over 1. Let's just say x equals to y minus 1 over 2, z minus 3 over negative. What if you're given a point to a line? So here's a point, here's a line. In that case, you can come up with a line equation that passes through it, that's perpendicular, and you can find this distance. So that's one way to do it. Or another way to think about this is you can come up with this as a you can write this as a parametric form. So x is t, y is 2t minus plus 1, z is negative t plus 3. And then think about it this way. It's basically measuring the shortest distance between this point to that point. Right? That's what we're looking for. The shortest distance between some arbitrary point on this line. Among all the possible distances they can measure, the smallest one is actually called the distance, right? So now you have an optimization question, which is solved by the following way. If I call this L, then L squared is, I put L squared is because I want to get rid of the square root. It's basically the differences between 1 minus t squared, negative 2 minus 2t plus 1 squared, plus 3 minus negative t plus 3 squared. Let's see. Then you can expand it and say L squared is t squared minus 2t plus 1. That's what you get if you expand this. Let's see, that's 2t, negative 2 minus 3, so 2t plus 3. So that will be plus 4t squared plus 4t, no, 2 times 12t plus 9. And then the last one will be just simply t squared, which is 6t squared plus 10t plus 10. And you're trying to find the minimum of this function. How do you find it? You differentiate and say equal to 0, right? So if I take L squared and differentiate it, it's 12t plus 10. Saying this equal to 0, we get t equals to negative 10 over 12, which is negative 5 over 6. So this function will have its minimum when t is negative 5 over 6, and therefore L, when t is equal to negative 5 over 6, is the square root of this thing, 6 negative 5 over 6 squared, plus 10 negative 5 over 6, plus 10. So you can get this as a square root of 25 over 6 minus 50 over 6 plus 10. That's 60 over 6 minus 25 over 6. So 60 minus 25, that's 35, right? So that's going to be square root of 35 over 6.
What is that, Ben?
Hmm?
What is that?
That's the distance between the point and the line given. That's height.